In this tutorial, we will show how to quickly model, analyze, and design a concrete building using ETABS 2013. The building will have 6 stories, each 12 feet in height. There are 4 22-foot bays in the X direction and 3 18-foot bays in the Y direction. The floor slabs are 8 inches thick. The lateral force-resisting system consists of interior shear walls and perimeter moment frames. The building will be subjected to both gravity and wind loads. Starting the program, we click the New Model button. On the Model Initialization form, we have 3 options for initialization. We can use previously saved user defaults, settings from another model, or as we will use here, the built-in settings. We will use the US customary units, and if we hold the cursor on the information icon, we can see the units that will be used. We will use the ACI 31811 concrete design code. The steel section database and steel design code are not applicable for this model. Click the OK button to display the New Model Quick Templates form. On this form, we will start by setting the grid spacing. Set the number of grid lines in the X direction to 5, in the Y direction to 4, the X direction spacing to 22 feet, and the Y direction spacing to 18 feet. For the story dimensions, set the number of stories to 6, and verify that the story heights are set to 12 feet. Click the Flat Slab with Perimeter Beams button, and on the Structural Geometry form, enter 6 feet for the drop panel size. Next, we will enter structural properties. Start by clicking the ellipsis button adjacent to the column drop-down list. On the Frame Properties form, several predefined default sections are available, but we are going to create our own sections by clicking on the Add New Property button. On the Frame Property Shape Type form, click on the Rectangular Section button under Concrete. Here, we will define a concrete column section, which we will call Concrete Column. We will set the depth to 24 inches so that the column will be 24 inches square. If we wanted to reduce the stiffness of the section, we could do so by clicking on the Modify Show Modifiers button and entering a value less than 1. Click on the Modify Show Rebar button to review the reinforcement specifications for the column. Click OK on the Frame Section Property Data form, and Concrete Column should be shown on the Properties list. Next, we will define a Beam Section property by clicking on the ellipsis button adjacent to the Beam drop-down list. Again, we will add a new property, also rectangular, that we will name Concrete Beam. This will be our perimeter beam. Set the value in the Depth Edit box to 30 inches. Click the Modify Show Rebar button, and on the Reinforcement Data form, select the design type as M3 for a beam, and then click OK. Click OK on the Frame Properties form, and note that Concrete Beam is the selected beam section. Verify that Slab 1 is an 8-inch slab by clicking on the ellipsis button, selecting Slab 1, and then clicking the Modify Show Property button. Lastly, Drop 1 is a 15-inch thick drop panel property. Now we will add gravity loads. In addition to the self-weight of the building, there will be an additional dead load of 25 pounds per square foot for partitions and equipment, and a live load of 80 pounds per square foot. In the dead load additional edit box, enter 25 psf. In the live load edit box, enter 80 psf. Verify that the rigid option of the floor diaphragm is selected, and click the OK button. Click the OK button on the templates form to display the model. A plan view is displayed on the left and a 3D view on the right. The number and arrangement of windows may be controlled using the Windows List button. Save the model using the File menu Save command. It is a good idea to save the model often. Now, move down to the Drawing and Selection drop-down list in the lower right-hand corner that reads One Story, and select All Stories from the list. With all stories selected, additions or changes made to one story will apply to every story in the building. Next, we will add floor openings for the elevator core. Click the Draw Rectangular Floor button, and in the Properties of Object Form docked in the lower left-hand corner, select Opening from the Property drop-down list. Opening will create a void where the shell object is drawn. Check that the Snap to Grid Intersection and Points command is active, and it is active when the button is depressed. Click and hold the left mouse button at column C3 while dragging the cursor to column D2. Release the mouse button to draw the opening. Click the Select Object button to leave the draw mode. Next, we will remove the columns around the opening. Hold down the Control key and click on column C3. On the selection list, highlight the column object and click OK. The column at C3 is selected over its entire height because the All Stories feature is active. Note that 6 frames are selected in the status bar. Repeat this process at D3, D2, and C2 to select the other columns. And then click the Edit menu, Delete command to remove the columns. Now we will draw the core walls using the Wall Stack feature. The Draw Wall Stacks command allows for the rapid creation of walls based on a wide range of wall layouts. For our model, we will use the E-shaped layout. In the Layout tab, we will set the LX length to 18 feet and the LY1 and LY2 lengths to 11 feet in order to match the size of our floor opening. We will set the thicknesses for all of the walls to 14 inches. Click the OK button and note that the orientation of the wall stack does not fit the opening. In order to make it align, in the Properties of Object box, change the angle to 90. Verify that the wall stack will be drawn over the entire building height, stories 1 through 6. In the plan view, align the wall stack such that the top left corner of the stack is located at C3 and then click. Click the Select Object button to leave the draw mode. Next, we will add a wind load pattern. In the Model Explorer window, expand the tree under the Loads branch. If for some reason the Model Explorer is not displayed, click on the Options menu Show Model Explorer command. Go back to the Model Explorer window and expand the Load Patterns branch. And note that dead and live load patterns are already defined. Right-click on the Load Patterns branch, and on the menu, click the Add New Load Pattern command. In the Load Edit box, type Wind for our new load pattern. Select Wind from the Type drop-down list, and from the Auto Lateral Load list, select ASCE 7-10, and then click the Add New Load button. With the Wind Load pattern highlighted, click the Modify Lateral Load button. And on the Wind Load pattern form, make sure that the Exposure from Extents of Rigid Diaphragms option is selected. By applying the wind load to the rigid diaphragms, the program will automatically apply all of the wind load cases prescribed in the ASCE 7-10 code. The various directions and magnitudes of wind may be reviewed by holding the cursor on the information icon. Note that the case variable is set to create all sets. Verify the other information on the form, including the exposure heights, and click OK. Click OK to close the Define Load Patterns form. And note that the wind load pattern has been added to the Model Explorer. In the last step, we asked that wind be applied to the rigid diaphragms. The extents of the diaphragms can be shown by clicking on the Set Display Options button and checking the Diaphragm Extent option. The radial lines indicate the extent. Right-click anywhere on the slab, and note that the slab is assigned to diaphragm D1. And by going to the Define menu, Diaphragms command, we can see that diaphragm D1 is indeed a rigid diaphragm. Click the Cancel buttons, and then turn off the Diaphragm Extent display. Next, we will add P-delta effects to our wind load case. Expand the Load Cases branch in the Model Explorer window, and right-click on the wind load case. In the context-sensitive menu, select the Modify Show Wind command. On the load case data form, note that for the wind case, the default setting for P-delta is none. Click the Modify Show button to see the preset P-delta options form. For P-delta, we have three options: none, a P-delta based on mass, which is non-iterative, or a P-delta based on loads, which is iterative. Select the last option, and for this model, we will specify the P-delta load combination to be 1.2 times dead plus 0.5 times live. Now we are ready to analyze the ETABS 2013 model, which we can do by clicking on the Run Analysis button. When the analysis is complete, the program automatically displays a deformed shape of the model in the 3D view, and the model is locked, preventing any changes that would invalidate the analysis results. Now we can display the results. In the Model Explorer window, click on the Display tab and expand the Model Windows branch. Expand the 3D View branch and then the Display branch. Under Display, select Frame Forces option. This displays the moment diagrams for the dead load case. Go to the Display menu, Force Stress Diagrams, Shell Forces command. And for the dead load case, select component M11 and click on the Display on Deform Shape option from the Contour option drop-down list. And then click OK. Make the Plan View active by clicking on the Plan View tab and click on the Show Deform Shape button. On the form, select Wind as the load case and click OK. This is the first wind step, of which there are 12. The other display shapes for wind may be displayed by clicking on the VCR buttons in the lower right-hand corner. Click the Show Undeformed Shape button to reset the view. Next, we will design the concrete frame. Right-click on a perimeter beam and note that on the Design tab, the design procedure is listed as concrete frame. Click the Design menu, Concrete Frame Design, View Revise Preferences command, and verify that the design code is set to ACI 318-11. Review the other parameters and click OK. To start the design, click on the Concrete Frame Design button. When the design is complete, the longitudinal reinforcing in the perimeter beams is displayed. Use the Move Down in List button to change the display to Story 1. And then right-click on a beam to show the design information form. This form shows the required reinforcing steel for each design combination at different locations along the beam. The value highlighted is the largest value and may be either top or bottom steel. Click the Envelope button to display the beam section design report. Print or save the report for future use. Click the Design menu, Concrete Frame Design, Verify All Members Passed command to confirm that all frame members are adequate. Click the Clear Display of Assigns command and then switch the 3D view to undeformed. Next, we will design the shear walls at the elevator core. Set the Plan View to Active, and then go to the Select menu, select Object Type command. Highlight Walls, and then click Select, followed by Close. Under the View menu, click the Show Selected Objects Only command. This results in only the walls being displayed. Click the Define menu, Peer Labels command, and note that the program has predefined two peers, P1 and P2. We will add two additional peer names, P3 and P4. Each wall segment in our model will have a unique peer name. In the Drawing and Selection drop-down list, activate All Stories. In the Plan view, left-click once on the wall that lies along grid line C to select it. The status bar should show 6 shells selected for all 6 stories. Click the Assign menu, Shell, Peer Label command, and on the form, highlight P1 and click the Apply button. Note that P1 is applied to the wall just selected, but all the other walls have P2. P2 was assigned automatically by the program as a default to all the walls. For our model, only the middle wall will remain as P2. Click once on the wall along grid line D and highlight P3 on the form and click the Apply button. Lastly, window around the wall on grid line 2, highlight P4 and click the Apply button. And then the Close button. With the plan view still active, click the Set Default 3D View button. Click the Design menu, Shear Wall Design, View Revise Preferences command, and verify that the design code is set to ACI 318-11, and then click OK. To start the design, return to the Shear Wall Design menu and click on the Start Design command. When the design is complete, the pier longitudinal reinforcing is displayed. A right-click on a wall brings up the Shear Wall Design Report, which shows comprehensive design information about the pier. Click the Clear Display of Assigns command. Change the view to a plan view. And click the View menu, Show All Objects command. To view a table with the pier design information, select the Tables tab in the Model Explorer window and expand the Design branch and then the Shear Wall Design branch to expose the Shear Wall Pier Summary leaf. Right-click and select the Show Table command. After reviewing this table, close and then save the model. This concludes this introductory tutorial on ETABS 2013.